All right, welcome to the second chapter. We are finally starting to get into a little bit more of difficult concepts. This is all based off of chemistry, so it's going to be a brief overview of some things you probably already did last year. We are not going into like complete details, so do not feel like you have to know or memorize everything. I will tell you what are the important concepts here. So matter and organic compounds. This is the same reading. Excuse me, it's not the same reading. It's a different reading, but I'm breaking the reading up into two parts. I've realized my videos have been a little bit too long. So this is part one of the reading, matter and organic compounds. Part two will be all about carbon-based carbon-based systems and more of like carbs and lipids and proteins and different things like that. Here's what you should know by the end of this video. So this may seem like a very easy video. You should be able to define elements and compounds. You should be able to classify matter into elements, compounds, and mixtures. You should be able to identify key features of the periodic table. And you should be able to distinguish between different elements, compounds, and mixtures. So the first thing I want to talk about is the idea of chemical substances. So chemical substances is basically just matter. Okay, and I'm going to define it here in a minute, but we should probably know what matter is. Matter is anything that has mass and takes up space. You've probably heard that since the beginning of your science career. Matter is everything that has mass and takes up space. So things like lightning are not considered matter, but like my desk is considered matter. It's considered solid. A chemical substance, more specifically, is matter that has a definite composition or the same composition throughout. There are different types of chemical substances. Two of those types are elements and compounds, and we'll spend time talking about that. When we classify matter, matter can be classified into two different classifications. So like I said, matter can be classified into chemical substances and mixtures. And there we can further break down chemical substances into elements and compounds. So elements and compounds are very similar in the fact that they're both considered pure substances. So what I mean is that they're the complete same composition. Elements are I shouldn't say most pure, but these are the substances that cannot be broken down. They are composed of atoms. And I'm going to spend time talking about each three of these components in detail here later. And if you want to go ahead and number those, I keep bulleting and I keep forgetting. Go ahead and number those. So matter can be broken into three different classifications: elements, compounds, and mixtures. All right, so let's talk about elements first. So elements are pure substances that cannot be broken down into other substances. So what you got is what you got. So if I showed you a chunk of aluminum, all it's made up of is aluminum atoms. That is it. Every single atom that makes up that aluminum is just aluminum. There's nothing else mixed with it. It's very much a pure substance. There are a total of 120 elements found on the periodic table. If you don't know what the periodic table is, the next slide, I'll show you what that looks like. Also, I have one in my room. I have two in my room, actually. These are made up, like I said, the elements are made up of one type of atom. There are three different types of elements. You have metals, metalloids, and nonmetals. I would say about 75% of your periodic table is made up of metals. And then about 15%, I think if I'm doing my math right, yeah, about 15% is nonmetals, and then 5% is metalloids. And I'm going to show you what these look like on the periodic table next. When you are dealing with elements, they are always distinguished by a symbol. So B stands for boron. That is the only symbol for boron. There is no other symbol. The number 5 represents the atomic number. And then obviously you have the name at the bottom. Now you'll see sometimes that there's a lot more information in here. But for the most part, you'll see at the bottom, you'll also may see the atomic mass. But we're not going to go into those details. Look at here, I spelled my name. How sweet is that? Here's the periodic table that I was going to tell you about. I am going to highlight and show you the, well, I guess it's already on the picture here, and it tells you, this table is really nice because it breaks the metals down even further, but we are not going to learn that in this class. If you take chemistry, you'll learn that in detail. But here are all the metals. So you have aluminum. I'm trying to mark them all so I don't mess up here. Here are all of my metals. Oops, I forgot these ones here at the bottom. Okay, so all of this, to include this table down here, are considered metals. That does not include hydrogen. Hydrogen and all of these are considered non-metals. Then you have what's known as this pretty little staircase. This looks like a mess. If you were to just download this, it would just look like a mess. That pretty little staircase are known as the metalloids. Like I said, you can break elements down even further and call them either metals, metalloids, or non-metals. That is as much as I expect you to know about the periodic table and about elements. All right, so the second classification of matter is known as compounds. So compounds just take the idea of elements and just kind of adds a little bit more to it. So compound, again, is a pure substance because it's still the same throughout, still made of the same number of something, if you will. So compound has a unique composition that is always the same. Okay, so you can't, let's say, or you know what, I'll go into the example here in a minute. Smallest particle of a compound is called a molecule. Okay, so let's think about water as our example. So a molecule of water always contains 1 atom of oxygen and 2 atoms of hydrogen. Always going to be that. And if you know H2O, that's a molecular formula. Okay, so it's always going to contain 2 hydrogen, 1 oxygen. If I had the ingredients H and O, and I said, let's make water, you'd always need to use 2 hydrogen, 1 oxygen. You can't just say, oh, well, I have 2 hydrogen and I have 2 oxygen, and you'd have H2O2. That's a completely different substance, not the same as H2O. So even if it's made of the same stuff, still completely different just because of the amount of something, okay? And then some other important parts about compounds is the reason why these things stick together so nicely is because they're chemically bonded. These hold molecules together, and there are different types of chemical bonds, and we're going to learn about those a little bit, but we're not going to spend a huge amount of time on them. And then when these things actually change, it takes a lot to actually change a compound. You have to actually chemically change the compound. And if you learned about chemical changes and physical changes, you probably know a little bit of what I'm talking about. Chemical reaction is a process that changes chemical substances into another. So in order to change water into a completely different substance, you actually need to have a chemical reaction, a permanent change to this particular compound. And finally, the third classification of matter is known as mixtures. So these are not pure substances because the amount of the substance you put in it can vary. So, for example, if I have chocolate milk, that's considered a mixture because one time I can pour, let me see here. Let's say I put a cup of regular milk and I put 2 scoops of cocoa powder into my milk and I mix it all up. Okay, that's one time. I still have chocolate milk. It looks like it's all the same, but then the next time I make it, I only put half a cup of milk and 2 scoops of chocolate milk. Of cocoa powder. It would still be considered chocolate milk, but it's the same mixture. So there are different kinds of mixtures. There's what's known as homogeneous and heterogeneous, and you'll also hear them said as homogeneous and I can't even say it. Homogeneous and I can't say the other one. Just ignore me right there. All right, but let me explain homogeneous. Homogeneous is a mixture that is a uniform in composition. That means you cannot just pick it apart easily. Okay, so a good example is like detergent. You kind of would expect that all of your detergent is the same. Another good example is homogenized milk. So if you go and you were to milk a dairy cow right now and then let the milk sit overnight, it would separate and it would be like chunky on the top. And that's just the fat mixing from the more watery substance. What farmers do, and it's not unhealthy to drink that, but what farmers do to avoid people thinking it's rotten, they homogenize the milk. They make the milks the same to kind of make it so it doesn't like chunk out on you. So homogenized it looks the same throughout. It's very hard to pull apart. In comparison to a heterogeneous mixture, this mixture that is not this uniform in composition, a good example is trail mix. Because if I make trail mix, I could easily grab a handful and pick out the pretzels that I don't want in there or the peanuts that I don't want in it. I can easily take those out. The handful I grab one time could be very different from the handful I grab the next time. This is more of a visible mixture. You can definitely tell heterogeneous mixtures in comparison to homogeneous mixtures. Now, I gave you the example of water as a compound. Water is a tricky one because it can and probably always will be used as a mixture, only because to find water in its most pure state is almost impossible on Earth. Because when we get water from our streams or our wells, there's a possible chance of contamination. So at that point of contamination, it becomes a mixture because it's no longer just made up of hydrogen and oxygen. It's made up of hydrogen, oxygen, minerals, possibly some kind of runoff. So different things can make it up. So anything that's a compound can't possibly become a mixture. This may seem like I went really fast. I do apologize. If you have any questions, please don't hesitate to ask. You guys have been doing really well using the question feature. I do appreciate that. What else was I going to say? This is part 1 of this video. The next portion may be a little bit more overwhelming, but hopefully we can bring it all together and it makes a little more sense.